Okay, so just going to look at another horizontally resisted motion question. So an object has a mass of 4 kilograms and it moves to the right horizontally with initial velocity of 10 meters per second and a resisted force of 20 v squared. V is the velocity after t seconds. Find the acceleration in terms of v. The acceleration in terms of v. So the sum of the forces is equal to mass times the acceleration. So the mass is 4 times the acceleration equals the sum of all the forces. Now the only force acting in the horizontal direction is minus 20 v squared. There's no other forces because even the weight force will go down, so it doesn't affect the horizontal motion. So that means that the acceleration is equal to minus 5v squared. So acceleration is minus 5v squared. Now in the first part, we want the velocity in terms of t. So that's 1, the velocity in terms of t. So we have to replace that with dv on dt is minus v squared. And then that will be, keep that 1 on v squared dv equals minus 5 dt. So when you integrate that, that'll be, bring that up to the top, minus 5t dt. So you end up with v to the minus 1 on minus 1 equals minus 5t plus c. So time equals 0. V initially is 20 meters per second, I think we had. No, 10. 10 meters per second. So that means that is minus 1 on 10 equals minus 5 times 0 plus c. So c is minus 1 on 10. So that means that we have v to the minus 1 equals minus 5t minus 1 on 10. Minus 1 on v equals, now I better get a common denominator here, minus 50t minus 1 on 10. The signs will go out because there's a negative in all of them. Let's flip it. V is 10 on 50t plus 1. Okay, so that's done. Now the last part, how far did the object move from its initial velocity to a velocity of 5 meters per second? So how far means we're after x, and we're given velocities. So if we start with the acceleration was minus, let's go back up and just double check, minus 5v squared. And we're talking from v is 10 to v equals 5. So replace that with v on dv on dx. Always use that as your first port of call. Your backup is to use d dx over half v squared. So you put that over v squared dv. Now I think I might actually leave the minus 5 there and make that dx. It's just a bit nicer. So you get 1 on v dv equals minus 5 dx. So when we integrate this, so we don't have to worry about the plus c, the velocity is going from 10 to 5, and the time is going from 0. I mean, the displacement is starting from 0 to, and we'll just put x for the displacement at that time. Okay, you could put a d or any letter in there if you wanted to. So that's going to be ln v, and we're going to go from 10 to 5. And this is minus 5x, and we're going to go from 0 up to x. I'll even put a different character x. Let's put a big X. So it's ln 5 minus ln 10 equals minus 5x minus 0. So that's ln a half, because it's 5 on 10, equals minus 5x. So x will be minus 1/5, ln 0.5. So really, I mean, you could change if you put the negative there, you get minus 1/5 ln 0.5 to the minus 1, which will make it 1/5 ln 2. And that's the distance that it travelled. I mean, you could leave it like that as well. Note it's a negative because a half is less than 1 and minus 1/5 is negative. And a negative times a negative is a positive.